Hey everyone, welcome back to Unusual Science. Today we're diving into 10 mind-boggling scientific facts that'll leave you saying, no way. Get ready to have your minds blown wide open. Let's jump right in. You heard that right. It might sound like a paradox, but it's a fascinating reality of physics. Water can boil and freeze at the same time thanks to the triple point. This unique phenomenon occurs under very specific conditions. Under these specific conditions, water can exist as ice, liquid, and steam simultaneously. It's a delicate balance of temperature and pressure. Picture this. In a lab, you control the pressure and temperature of a dish of water. By carefully adjusting these variables, you can witness this incredible state. Lower the pressure, and the boiling point decreases. This means water can start to boil at a much lower temperature than usual. Lower the temperature and it nears the freezing point. This delicate balance is key to achieving the triple point. At the triple point, water boils and freezes at the same time. It's a mesmerizing sight, seeing water in all three states at once. This happens at a very low pressure, about 0.006 atmospheres. That's less than 1% of the atmospheric pressure at sea level. So, you won't see this in your kitchen sink, but it's a fascinating example of science pushing boundaries. It shows how altering conditions can lead to extraordinary phenomena. Remember, the triple point of water shows that the impossible can become possible. It's a testament to the wonders of scientific exploration and discovery. Hold on to your beakers. The Mpemba effect means hot water can freeze faster than cold water under certain conditions. It sounds bonkers, but it's true. One theory is that evaporation reduces the amount of water, making it freeze faster. Another idea is that convection currents in hot water distribute heat more efficiently. Some scientists think the bonds between water molecules in hot water are stretched, making it easier to form ice. The Mpemba effect is a mystery that shows how much we still don't know about the world. Next time you're making ice cubes, appreciate the wonder of water's quirky freezing habits. It's a reminder of the fascinating mysteries science still has to unravel. Stay curious. Ever notice how hot cocoa sounds different when poured compared to ice-cold lemonade? You're not imagining things. The sound difference is real and fascinating. The temperature of water affects the sound it makes. This phenomenon is due to the physical properties of water at different temperatures. Sound travels through materials as vibrations, and these vibrations behave differently depending on the medium they pass through. The density of the material plays a crucial role in how sound waves travel. Denser materials slow down the vibrations, while less dense materials allow them to move faster. Hot water is less dense because its molecules move faster and spread out. This increased molecular activity creates more space between the molecules. This allows sound waves to travel more quickly through hot water, resulting in a higher pitch when you hear it being poured. The higher pitch is due to the faster movement of sound waves. Cold water, on the other hand, is denser, so sound waves travel more slowly, creating a lower pitch. The molecules in cold water are packed closely together, restricting the speed of sound waves. It's like the difference between high and low notes on a musical instrument. The same principle applies to the sounds of hot and cold water. So, next time you're around flowing water, listen closely. Whether it's a river, a faucet, or a stream, the temperature of the water can change the sound you hear. You might be surprised by what you hear. This simple observation can open up a whole new world of understanding about the science in our daily lives. Science is all around us, in the most unexpected places and moments, even in the most ordinary things. So keep your ears and eyes open, and you might discover something new and fascinating every day. Let's raise a glass to the wonders of physics and beer. Specifically, Guinness beer, a drink that has fascinated both beer lovers and scientists alike for years. Most beers are carbonated with carbon dioxide, which creates large, buoyant bubbles that rise quickly to the surface. But Guinness is different. It's nitrogenated. Nitrogen forms smaller, more stable bubbles, giving Guinness its signature creamy texture and smooth mouthfeel. This is why a pint of Guinness looks so different from other beers. These tiny nitrogen bubbles actually sink in the glass due to a fascinating phenomenon known as the bubble cascade. This is where the magic happens. When poured, nitrogen bubbles rise to the top, creating an upward flow in the center of the glass. This is the initial stage of the cascade. This upward movement pushes the beer against the sides of the glass, creating a downward flow along the edges. It's a beautiful dance of physics in your pint. Tiny nitrogen bubbles get caught in this downward flow, making them appear to sink. This is why you see bubbles moving downwards along the sides of the glass. It's like a miniature whirlpool of beer in your glass, a mesmerizing sight that adds to the enjoyment of drinking Guinness. Next time you enjoy a pint of Guinness, take a moment to appreciate the science behind those mesmerizing bubbles. It's not just a drink, it's a marvel of fluid dynamics. Even the simplest things like a glass of beer can be full of wonder when viewed through the lens of science. Cheers to that! Let's journey to the center of the Earth, where it's as hot as the sun's surface. The Earth's core reaches about 10,800 degrees Fahrenheit. This heat comes from the Earth's formation and radioactive decay. Billions of years ago, the Earth formed from a swirling mass of dust and gas generating immense heat. This accretionary heat is still trapped in the core. Radioactive elements like uranium and thorium also release heat through decay. This intense heat drives geological processes like plate tectonics and volcanic eruptions. It's the engine that keeps the Earth alive and kicking. The Earth's core is a blazing inferno, shaping our planet in incredible ways. Hold on to your safety goggles. Some metals react so violently with water that they burst into flames. We're talking about alkali metals like sodium and potassium. These metals have a single electron in their outermost energy level. When they hit water, they donate this electron, forming hydrogen gas and hydroxide ions. This reaction releases a tremendous amount of energy, causing the hydrogen gas to ignite. It's a dramatic demonstration of chemical reactions' power. These reactions are incredibly dangerous and should only be performed by professionals. Chemistry is exciting, revealing the incredible forces that govern matter's behavior. Get ready to feel incredibly small. There are more stars in the observable universe than grains of sand on all Earth's beaches. Astronomers estimate about 200 billion trillion stars in the observable universe. That's a 2 followed by 23 zeros. And that's just the observable universe. The universe likely extends far beyond what we can see. Our planet, solar system, and galaxy are just tiny specks in the grand scheme. It's humbling and awe-inspiring. The universe is vast and mysterious, full of wonders we're only beginning to understand. Stay curious and keep exploring. The largest living organism on Earth isn't an animal or plant, but a fungus. The humongous fungus in Oregon's Malheur National Forest covers over 2,385 acres. Most of it lives underground as a vast network of mycelium. The fruiting bodies we see above ground are just a small part. The mycelium has been spreading for thousands of years. This single organism has been alive since long before the pyramids were built. Fungi play a vital role in ecosystems, breaking down organic matter and recycling nutrients. Next time you see a mushroom, appreciate the hidden world beneath your feet. You might be standing on a fungal giant. This next fact is straight out of a horror movie. A fungus called Ophiocordyceps unilateralis infects ants, takes control of their bodies, and turns them into zombie-like slaves. The fungus infects carpenter ants and manipulates their behavior. It forces the ant to leave its colony and climb down to the forest floor. The ant then climbs up a plant stalk and clamps onto a leaf. The fungus continues to grow, consuming the ant's internal organs. Eventually, a stalk grows out of the ant's head, releasing spores to infect more ants. It's a gruesome cycle of parasitic manipulation. Ophiocordyceps has evolved this method to ensure its survival. Nature is full of surprises, some more unsettling than others. In the ultimate bouncy ball showdown, a glass ball can bounce higher than a rubber ball. It sounds counterintuitive, but there's a scientific explanation. When a ball is dropped, its potential energy converts to kinetic energy. Rubber balls absorb more energy upon impact, leaving less for the bounce. Glass balls are more rigid and absorb less energy, resulting in a higher bounce. However, glass balls are more likely to shatter on hard surfaces. So, stick with rubber balls for your bouncing pleasure. Science can be full of surprising and counterintuitive facts. And there you have it. 10 weird and unusual science facts to amaze your friends and spark your curiosity. Which fact blew your mind the most? Let us know in the comments below. Don't forget to like, subscribe, and hit that bell icon for more fascinating science content. Until next time, stay curious.